Hey folks, welcome to part 2 of our developer blog covering animated components. If you haven't seen the previous video, check it out, link in the description or in the card appearing in the corner. I'm going to highly recommend you watch that before you watch this one. This video is going to fix what was wrong in the previous approach with regard to if your mouse cursor enters the component and then leaves it faster than the lambdas can do their thing for it. All right, so just to kind of show what that is, here's where we are currently at. Okay, so if the cursor enters and then exits before the appropriate one-shot lambda fires, then we get that weird graphical effect that you see here. So this is what we're going to fix in this approach here. All right. Let's close this and get to work. All right, so first of all, we're not going to use this anymore. Okay, we're not going to use this. We're not going to use any of this fade out stuff. What we're going to do is use a timer. We're just going to go full timer, all right? That means we're not going to use this thing either. All right, we can just comment that out because it's not going to be used. Public component, public timer, all right? This means that we now need a constructor that will allow us to call start timer, hertz 60, all right? And then we're going to need a timer callback, okay. Void timer callback, override, like that. All right, now what's going to happen, and this is similar to the way that MIDI keyboard state and MIDI keyboard component work. We're going to follow that same model. So void animated component timer callback. What's going to happen is every time the timer fires, we're going to check to see whether or not we should repaint. So that means we need something to change that's going to tell us if we should repaint or not. All right. So we need a Boolean val that says whether or not repaint. So bool update equals false. Okay. Whenever your mouse goes in, you're going to update. Okay. Update equals true. All right. Whenever your mouse exits, update equals false. True. All right. Now in the timer callback we have if update repaint. All right. Now in here, this is where we figure out which way to go. Now before we used a counter to climb up and a counter to climb down. So what we need now is something to kind of indicate if we're fading in or fading out. So we'll use an enum for that. Enum, lowercase, enum class. Excuse me. Let's see. Fade direction. In, out. Those are our two choices. This is and then now we need an instance of that. Fade direction equals fade dir in. All right. So now, if our mouse is entering, we want to fade in. So we need to say fade direction equals fade dir in. And then when our mouse is exiting, we need to say fade direction equals fade dir out. Okay, so in our paint, we need to say if we are fading in, so if fade direction equals fade dir in. All right, we're gonna adjust what max steps is, and we're gonna adjust what this is. So this means, so before we were doing our counting outside of repaint, and repaint was doing, and paint was just using a static value. Whereas in here, now in paint, paint is going to actually do the calculation of our next step. So we go, okay, if we're supposed to update, I'm sorry, that's incorrect. If current step is, whoops, I got a bunch of extra words here going on. If current step is less than num steps up, because we're fading in, all right, we can increment current step plus equals 1. All right. Else Current step is already set to num there, so it means don't update anymore. Update equals false. All right. Same thing for the other direction. Okay. If current step is greater than 0, meaning we're working our way down, we need to say current step minus equals 1, and then else update equals false. All right, and this is the last thing, and update. Okay, because we run into the issue, if we don't check if we're supposed to update, we run into the issue of this becoming a negative value. Or in this case, say it's the very first time we call paint after doing update is true. Then this can be added, we can get 1 added to it for some reason, and it shouldn't. Okay, now max steps. Okay, this is we're going to run into an issue when we have different step up times and step down times. So max steps, we'll get rid of this, and this becomes a local, oops, this becomes a local value, right? Int max steps, like that. And now we want to say, if current steps is less than this, then our max steps is now our num steps up, right? If current step is less than this, then we want to say, max steps. I'm sorry, this needs to go outside of this, so that way it always gets set. Same for here. Max steps equals num steps down. All right, let's run that and see what kind of results we get. All right, cool. All right, that solves that problem. That was a pretty easy solution. Now, something to think about is the fact that this approach is based on the idea that we are doing fixed sized steps. So in that, what that means is like, this is always going to adjust by like, 0, 0.1, 0.2, 0.3, 0.4, 0.5 until we reach a certain goal. All right. So now the other approach that we want to try to do is a tick-based approach, and that means like, so you'll notice, say I set this to like a really long value, like say number steps up is 100, and this is 200. Okay. So what that means is I want this to take 100 steps before it, is fully faded in, and I want it to take 200 before it's fully faded out. Now, what that means, let's just take a look at what that looks like. Okay. Now, what that means is it takes a really long time for it to fully fade in, and it takes even. Oops, I missed a step. All right, I figured it out. Okay, so the issue is when we're fading out, we need to check whether or not our current step is at the maximum value for stepping up. And if it is, because we want it to count down from this value, we need to set current step to this value, okay? So that's what happens in mouse exit. If current step equals num steps, up, current step equals num steps down. All right. So now what's going to happen is it says this is going to increase all the way up to 100, and then it's going to get a mouse exit, and it's going to say, instead of jumping from 100 divided by 200, it's going to say current step is now 200, and it's going to do 200 divided by 200. 199 divided by 200, 198 divided by 200, etc., etc. That looks like this. Fade in all the way. Okay, fade in all the way. Take a long time to fade out. All right, that's what that does. All right, we'll put this back to 10 and 20. Okay, just take a look at that one more time. All right, so with regarding tick-based approach, what we want to do is try to picture a ruler in our head. So what we're doing is, this is, the current state that we begin with is where everything is at 0. Now, what we want to do is by frame 30, we want to increment some value to here. Now, let's pretend that, every frame we add a fixed amount to this value. And we're trying to get, so every frame we add a fixed amount to this value. And then when we reach frame number 30, we're going to stop adding to it. Okay, so we're coming along, and then at frame 20, we get a mouse exit. Okay, so now at this point, what we want to do, we didn't make it to our full value, whatever our counter is at, it didn't make it all the way to 30. But it's time to start counting down. Now, the way we were doing it before, if we were just adding one whole number, if we were to do that, we start subtracting 1, we're going to be done here at 40. Okay, we're going to be done here at 40. We're not going to be done 60 frames later, which is what we actually want. So what we need to do is figure out what value do we add or subtract from our current step to make us count down from 20 frames to 20 plus 60 frames and reach 0. Okay, so that's the problem that we're trying to solve. And then the other thing that happens is, what happens if when we get to, we're halfway through our 60 frames and we get a mouse enter, now we need to increment back up to 30, all right? So here we made it 20 frames out of our 30 required frames to fade in. Then we got a mouse exit. Now we got to go 30 frames out of our 60 to get to 0 before a mouse enter came in. And now we're going to go the remaining. And now we're just going to keep fading in, hopefully all 30 frames before we are just at our desired end color level. All right. So that's what we're going to figure out how to implement. All right, so let me explain the whole approach that ends up getting used. And this borrows pretty heavily from Juice's linear smoothed value. The main difference is that Juice's linear smoothed value is designed to operate over a bank of samples, whereas here I just need the ramp functionality of it. So I literally just stole a whole bunch from it, actually. First, we start out with, we have our target value that we can set. We have our current, get the current value of it, get the step number. I'll explain what this one's for in a little minute. And then we have this tick thing. Now, what the tick thing does, well, first we have our linear ramp fader object. Actually, we don't use this anymore. We don't use any of the other stuff that was here. We just have our fader object. And we started off with the default value of 0. So what happens when this thing is first initialized is our starting value and our target value are set to whatever we pass into it. What we do is first, when an event happens, a mouse event happens, we need to set what we want we need to set our target level, what we're trying to increment to and over how many steps that we're trying to do that. Okay, so for mouse enter, we're trying to reach if you remember before, we had a ratio value that was going here for our interpolated width. Okay, so we're trying to set that to 1.0 and we're trying to do it over 30 frames. Now here we have, on the mouse exit, we're trying to get to 0 and we're trying to do it over 200 frames. So what happens when you set your target value? The target property becomes our step size. If you remember the explanation earlier where I said it's got to be like 20 minus 30 divided by 30, where 30 was our number of steps. That's this equation right here. And then our countdown is just, that's just like a safety check here to make sure, to see, like, we don't really care if our current value goes up or goes, above or greater than 0. What we're more concerned with is whether or not our countdown first we start at 30 steps, and we want to make sure that we never go past getting to 0. So that's what countdown is for. And then step num, I use this to just print out, well, you'll see in a second what happens. So as I said before, the paint function is where we had moved our calculation of our interpolated value. And the same thing happens here. The difference is now we have, if we're supposed to update, because we haven't reached our target value, then we tick the fader. And for ticking, what happens is we increment our current value by our step. That's this thing right here. We say we moved 1 full value closer to 0, and then we are currently on this step number. If our countdown is less than 0, then set it to 0. Set our current value that's going to get returned when this is called to our target value. Set our step num back to 0. This guy is just for rendering, and return true. I said return true because I needed some way of turning off. I need some way of changing the flag of whether or not we should update from true, which is set here, all the way every time we repaint. Needed some way to set it to false, and the best way to do that was to change tick such that if we reach our goal, return true, meaning we're done. If we didn't reach our goal, return false. All right, so it's somewhat complicated. It's a great little tool. The best part is that it's like a linear ramp that could totally be used for like envelopes or whatever, like graphical envelopes showing like values changing over time in a visual sense, not just auditory sense, like with a linear smooth value. Anyway, this looks like this. Oop, what's going on? Oh, I didn't need fader direction. I don't know why I deleted that. All right, here we go. I forgot. Well, actually, I'm not even using it, so we're going to get rid of it. Like that. We'll just comment it out. All right, we don't want code that isn't being used in our projects because it just, gets confusing. All right, here we go, one more time. All right, now if I mouse over these, well, just a note here, I'm doing 30 frames for the fade in and then 200 for the fade out. All right, we're currently fading out. All right, we'll do a fade in, okay? It almost gets to 30 and then it resets back to 0 because of, I just wanted it to see that. All right, it goes up. So now we get the behavior we wanted. All right, pretty neat. All right, we can hide this. We can change this to not be so bright. We'll go back to our mellow value. We'll change this to be nice and short. 20, make you 10. We'll get rid of our rectangle. We don't need our font anymore. All right, we'll run this one more time. And here we go. Got some nice rectangles that fade in, and they fade out a little too fast for me, so we'll make these fade out full 60 frames. All right, pretty cool. Awesome. So that explains the final tick-based approach, which I believe is the superior approach. The only problem with it, and this is just a general problem with doing timer callbacks to call repaint, keep an eye on this CPU usage and check out what happens when I run this thing. All right, it gets pretty high. Especially, like, we'll turn this stuff back on. Just draw a string, draw these rectangles. Just gonna run it one more time. Keep an eye on that CPU usage. This is something that a lot of people struggle with. All right, it's getting up there 28, 30%. Right. And that's just what happens when you're just drawing a ton of stuff at 60 frames per second. All right, I hope you enjoyed that. Thanks for checking it out again. Thanks to the audio programmer for having me do the first video on his channel. I hope you dug this, and I'll see you in the next one. Peace.